ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ವೆಲ್ಕಮ್ ಟು ಟೆಕ್ ಗರ್ಲ್ ಕನ್ನಡ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್. Briefly explain the recovery process. Explain the three phases of ARIS recovery technique. ARIS recovery process. The recovery process ensures that the database is returned to its consistent state after failures such as transaction failure, system crash, or media failure. It uses the log file to undo and the effects of incomplete transaction and redo the effects of committed transaction. ARIS algorithm for recovery and isolation. Algorithm for recovery and isolation exploiting semantics. This is the full form of ARIS, algorithm for recovery and isolation exploiting semantics. It's a widely used recovery technique. It has three main phases: analysis phase, scan, a redo phase, repeat history, undo phase, rollback. This is that determines the state of the system at the time of crash. Analysis phase. By scanning the log forward, identifies transactions, committed transactions, active which is incomplete, and dirty pages in the buffer. Then redo phase. Repeat history. Replays all actions of committed transactions to ensure that all their updates are reflected in the database. Ensures durability. Undo phase. Rollback. Rollback or undo all the updates of the transactions that were active which was not committed at the time of the crash. Ensures atomicity. Details about the three phases. Analysis phase. Scan. Starts from the last checkpoint in the log. Scans the log forward to end. Builds the transaction table and the dirty page table. Transaction table holds status of transactions committed or active. Redo phase. Repeat history. Scans the log forward from the checkpoint. Repeats redo all updates records of committed transactions. Uses dirty page table to avoid unnecessary redo. Ensures that all committed updates are in the database. Undo phase. Rollback. Starts from the end of the log and moves backward. Undoes the updates of all active or incomplete transaction using compensation log record CLR. Writes CLR to log and ensures those transactions are fully rolled back. Leaves the database in the consistent state. With the neat state transition diagram, discuss the different state of transaction. The transaction goes through a number of states during its lifetime. Active states of transaction. Active, the transaction is executing its read or write operation. Partially committed, the last statement has been executed. The transaction is waiting for the commit. All checks and log records has been already written. Committed, the committed record is successfully returned to stable storage. All updates are now permanent. Failed, the transaction cannot proceed due to an error or deadlock or crash. Aborted, the transaction has been rolled back. All its updates has been undo using undo. Terminated, the transaction has finished. either committed or aborted, and all resources are released. This is the state transition diagram. Active, partially committed, committed, terminated. First, it will be in the read or write operations. Then the last statement executed, it commits partially, it commits either it commits partially, or if it catches any error, crash, deadlock, timeout, etc., then it gets failed. If it catches errors after partially committed, then also failure before commit occurs, then it fails. Then undo or rollback happens, then it gets aborted. Otherwise, it commits the record which is written and it will be committed, then it releases all the resources even after committing, even after aborting, then it gets terminated. A transaction starts from the active state, it can end in committed or aborted state. After both, it moves to the terminated state. Explain the three phases of the ARIS recovery model. That is, ARIS algorithm for recovery and isolation, exploiting semantics. Recovery model has three main phases. Those are analysis phase, scan, redo phase, repeat history, undo phase, rollback. Starts from the last checkpoint in the log, scans forward to the end of the log, builds the transaction table TT and dirty table DPT. TT contains status of each transaction, active or committed, and the last log sequence number of its last update. DPT contains all dirty pages and the resettled SEN, earliest LSN that dirtied that page. At the end of this phase, we know which transactions were active at the time of crash and which pages were dirty. Redo phase, repeat history, starts from the smallest rec LSN in the DPT, scans the log forward, repeats redo all updates records for the page that are still dirty. An update is redone if the page is in the DPT and the page a lesson log records a lesson. Ensures that all committed updates, including those not yet written to disk, are reflected in the database. Uses DPT to avoid unnecessary redo operations. Undo phase or rollback starts from the end of the log. Considers all transactions that are still active in TT, rolls back, undo their updates in reverse order using CLR compensation log records, uses a priority queue ordered for the last LSN of each active transaction. Each undo generates a CLR and the transaction's LSN in TT is updated. When a transaction is completely undone, a end record is written and the transaction is removed from the TT. After undo phase, the database is brought to a consistent state. Summary, analysis, find what happened, redo, repeat all committed actions, undo, roll back incomplete actions. Discuss the timestamp ordering Protocol for concurrency control, timestamp ordering protocol. Each transaction Ti is assigned a unique timestamp, Ts of Ti, which when it enters the system, all read and write operations are checked using timestamps to ensure serializability. For every data item X, maintain two timestamps, RTS of X, WTS of X. Largest timestamp any transaction that has successfully read the X, RTS. WTS, write timestamp, the largest timestamp of any transaction that has successfully written the X. Rules: TS of Ti, timestamp of Ti, RTS of X, read timestamp of X, write timestamp of X. Read operation Ri of X by Ti, it is let Ts equals to Ts of Ti. If Ts of Ti is less than WTS of Ti, reject the read. Ti is too old. Aborts or rolled back. If Ts of Ti is greater than or equal to WTS of X, allowed the read. Set RTS of X and equals to max of RTS of X, Ts of Ti. Write operation Wi of X by Ti, let Ts equals to Ts of Ti. If Ts of Ti is less than RTS of X, then reject the write operation. Ti has the smallest timestamp than a transaction that has already read X, aborts are rolled back. Then if Ts of Ti is greater than or equal to WTS of X, allow the write. Set WTS of X equals to Ts of Ti. If RTS of X is less than or equal to Ts of Ti less than WTS, Thomas Wright rule. Ignore the right, absolute right. Do not abort Ti, simply discard the right. Then here is the example for that. Ts of Ti equals to 10, Ts of T2 equals to 20, RTS of X is 0 and WTS of X is also same. First one, T1 is R of X. Since the T1 is greater than R of X, it is allowed. Then RTS of X becomes 10. Then for T2 right of X, WTS of X becomes 20. Now T2 is W of X. W of X will be 10 right now. So T2 is 20. Is 20 greater than 10? Then this and 20 greater than or equal to 0. Yes, allowed. WTS of X is 20. Then T1 is W of X. T1 is 10. And W of X is nothing but 10 into RTS of X. Reject or abort T1. Then for T2, W of X again is 20 greater than this. Is 20 greater than RTS of X into 10 and 20 is equal to WTS of X and 20. allowed. WTF of x is equal to 20. So the properties includes produces conflict serializable schedules, deadlock free, no waiting, may cause the transaction abort restart. Thomas Wright rule reduces the unnecessary aborts.